A master vibe coding fundamentals in 25 minutes. I completely changed how I build applications in just 3 months. And it's not what you think. I went from writing thousands of lines of code to having AI assistants do most of the heavy lifting while I focused on the big picture. This isn't about replacing programming skills. It's about amplifying them through something called vibe coding. Most developers are still stuck in the old way of thinking, writing every single line manually. But what if I told you there's a fundamentally different approach that's already transforming how the best developers work? But here's the thing. Most people have completely wrong ideas about what vibe coding actually means. What actually is vibe coding? Let me clear up what vibe coding actually means, because the misconceptions are everywhere. Most people think it's just talking to AI and hoping for the best. That's like saying driving is just sitting in a car and pressing pedals. There's a method to this madness that separates successful vibe coders from those who end up frustrated and empty-handed. The biggest misconception I see everywhere is that vibe coding means you can skip learning how software works. People think they can just describe what they want and magically get a working application. What actually happens is they get confused, broken code that doesn't solve their real problems. The truth is more interesting and more powerful than that fantasy. Vibe coding isn't about replacing programming knowledge. It's about amplifying it through strategic AI collaboration. Think of it like this. A traditional developer is like a craftsman who builds furniture by hand, measuring every piece and cutting every joint manually. A vibe coder is like an architect who designs the building and then directs a team of specialists to execute the vision. Both approaches create something valuable, but the architect can build skyscrapers while the craftsman builds cabinets. The skills are different, but the architect still needs to understand how buildings work, what materials to use, and how all the pieces fit together. Here's the core concept that changes everything. Vibe coding is the art of communicating your vision to AI in a way that produces professional-grade applications. This requires understanding both what you want to build and how to translate that vision into actionable prompts. Most people focus only on the prompting part and wonder why their results are terrible. They're missing the foundation. You need to understand user needs, system architecture, data flow, and user experience principles. The AI handles the implementation details, but you provide the intelligence about what should be built and why. The key insight that separates successful vibe coders from everyone else is this. It's not about knowing less code. It's about understanding systems at a higher level. You need to think like an architect rather than a construction worker. Traditional programming teaches you to focus on syntax, algorithms, and optimization. Vibe coding requires you to focus on user problems, system design, and strategic decisions. You're working at the level of what should this application do for users rather than how do I implement this specific function. The AI becomes your implementation team, but you're still the one making the important decision. Let me show you what this looks like in practice. Here's a vague request that most beginners make. Build me a to-do app. The AI will create something generic that nobody wants to use. Now here's a structured prompt. Build a task management application for remote software developers who struggle with context switching between multiple projects. Include project grouping, time tracking integration, and status updates that work with Slack. The main user flow should minimize clicks when adding tasks during active development sessions. The difference in output quality is dramatic. The second approach produces something useful because it includes user context, specific requirements, and clear constraints. Why are traditional developers resistant to this approach? I understand the hesitation. Many developers spent years mastering syntax and algorithms. The idea of describing what you want instead of coding it line by line feels like cheating, but this resistance is actually holding them back from massive productivity gains. Software development has always evolved toward higher levels of abstraction. We moved from machine code to assembly language to high-level programming languages for the same reason we're moving toward natural language interfaces now. Each evolution made developers more productive by handling low-level details automatically. Vibe coding fits into the broader evolution of software development perfectly. We started with assembly language, where you controlled every memory address and processor instruction. Then we got high-level languages that handled memory management and provided readable syntax. Now we're moving to natural language interfaces that handle implementation patterns and boilerplate code. Each step removed tedious work and let developers focus on more valuable problems. Vibe coding isn't the end of programming, it's programming at a higher level of abstraction. What makes vibe coding especially powerful is that it operates on distinct levels of thinking, each building on the previous one. Most people try to skip straight to prompting without doing the mental work that makes AI collaboration effective. They're missing crucial layers of preparation that determine whether their project succeeds or becomes another abandoned folder on their desktop. The transformation in how you approach building applications is immediate once you understand these principles. Instead of starting with code, you start with user problems. Instead of focusing on implementation details, you focus on system design. Instead of writing every function manually, you guide AI assistants toward the right solutions. The result is faster development, better user experience, and applications that actually solve real problems, instead of just demonstrating technical skills. Vibe coding is a learnable skill with specific principles, not just casual conversation with AI. The developers who master these principles first will have a significant advantage as this approach becomes mainstream. They'll build applications faster, solve bigger problems, and create more value for users. But here's what most people don't realize. There's a systematic thinking process that makes all the difference between success and failure. The 4 levels of thinking that change everything. This systematic approach operates through 4 distinct levels of thinking that transform how you collaborate with AI. Most vibe coders fail before they even start because they jump straight into prompting without doing the mental work that makes AI collaboration effective. They see an AI assistant and think they can just describe what they want. They type something like "build me an app" and expect magic to happen. What they get instead is confusion, generic code, and frustration. The AI isn't broken, they just skipped the preparation that makes everything work. Picture this scenario. You want to build a task management app. Most beginners would open up their AI assistant and say exactly that. "Build me a task management app." The AI will create something, but it won't be what you actually need. It'll be generic, basic, and probably not something anyone would want to use. That's because you haven't done the thinking work that transforms vague ideas into clear instructions. Level 1 is logical thinking, defining exactly what you're building. This sounds obvious, but most people skip this step and wonder why their AI assistant seems confused. You need crystal clarity on your application's purpose. For our task management example, Level 1 thinking means moving beyond "I want to track tasks" to something specific like "I want to build a task management system for freelance designers who juggle multiple client projects and need to track time for billing purposes." See the difference? The second version gives the AI context about who will use this, why they need it, and what problem it solves. Without this foundation, everything else falls apart. Level 2 is analytical thinking, understanding how your application should work. This means identifying the core user flows, the main features, and the problems you're solving. For our task management app, analytical thinking involves mapping out what users actually do. They create projects for different clients. They add tasks within those projects. They track time spent on each task. They generate reports for billing. They need to switch between projects quickly. They want to see their progress visually. Each of these insights shapes how the application should function. The AI can't figure this out for you. You need to understand your users first. Level 3 is computational thinking, breaking down your vision into technical components. This is where you consider data flow, user interactions, and system architecture. You don't need to code it, but you need to understand it. For the task management app, computational thinking means understanding that you need a database to store projects and tasks, user authentication to keep data private, a timer system for tracking work, and a reporting system that calculates billable hours. You need to think about how data moves through the system. When a user starts a timer, what happens? When they generate a report, where does that data come from? The AI handles the implementation, but you provide the architectural vision. Level 4 is procedural thinking, optimizing for excellence. This is where you think about user experience, edge cases, and what makes your application not just functional, but exceptional. Here's where you consider questions like, what happens if someone forgets to stop their timer? How do you handle projects that span multiple months? What if a user accidentally deletes a project with hours of tracked time? How do you make adding new tasks as fast as possible when someone is in the middle of focused work? These details separate good applications from great ones. Let's walk through how this thinking evolves using our task management example. Level 1. I want to build a task management system for freelance designers who need accurate time tracking for client billing. Level 2. Users create client projects, add tasks within projects, track time with start-stop timers, categorize tasks by type, and generate detailed reports showing billable hours per client and project. Level 3. The system needs user accounts, a project database structure, a real-time timer system, data relationships between clients, projects, and tasks, and a reporting engine that calculates totals and formats data for invoicing. Level 4. Include keyboard shortcuts for quick task creation, automatic timer pause detection when the computer goes idle, backup systems for protecting tracked time data, and visual progress indicators that motivate users to complete projects. Here's the critical insight that changes everything. AI assistants perform dramatically better when you've done this thinking work up front. They can execute brilliantly, but they can't read your mind. When you provide clear, detailed instructions based on this 4-level framework, the AI understands exactly what to build and why. Without this preparation, the AI makes assumptions that rarely match your actual needs. Let me show you the stark difference in AI output. A level 1 prompt might be, create a task management app. The AI will build something generic with basic add-delete task functionality. A level 4 prompt might be, create a task management application for freelance designers who bill clients hourly. Include project grouping, integrated time tracking with automatic idle detection, keyboard shortcuts for rapid task entry during active work sessions, and detailed reporting that exports billing data in common invoice formats. The interface should minimize context switching between projects and provide visual progress indicators for project completion. The results are shocking. The level 4 prompt produces professional-grade functionality, while the level 1 prompt creates something barely usable. What makes this framework so powerful is that it works regardless of which AI tool you use or what type of application you're building. The framework transfers from simple personal projects to complex business applications. Once you understand how to think at these 4 levels, every project becomes more successful because you're providing AI assistants with the intelligence they need to create what you actually want. The transformation happens immediately when you start using this approach. Instead of hoping the AI will guess correctly, you guide it towards specific solutions. Instead of getting generic output, you get customized applications that solve real problems. But here's what most people don't realize. There's a specific way to capture and organize all this thinking that professional developers have been using for years. The product requirements document revolution. That document is the product requirements document, and it's revolutionizing how successful vibe coders approach their projects. This isn't bureaucratic paperwork that slows you down. It's the difference between building something useful and building something that works but nobody wants. Think about it this way. When you give an AI assistant vague instructions, you get vague results. When you give clear, detailed instructions based on a solid understanding of what you're building, You get applications that actually solve problems. The PRD forces you to think through all the details that matter before you start turning, which means your AI assistant can focus on implementation instead of trying to guess what you want. What makes a PRD effective for vibe coding is completely different from traditional software documentation. Traditional PRDs focus on technical specifications, system requirements, and implementation details. Vibe coding PRDs focus on user outcomes rather than technical specification. You're not telling the AI how to build something. You're telling it what the application should accomplish for users and why those accomplishments matter. This shift in focus helps guide the AI toward making decisions that enhance user experience instead of just creating functional code. Let me walk you through creating a PRD for a real project so you can see how each section guides AI toward better decisions. Imagine you want to build an SEO analysis tool for small business owners. Your project overview section explains that many small business owners struggle with website optimization because existing tools are too complex and expensive. Your target audience section describes business owners who understand their customers but don't have technical SEO knowledge. Your core features section includes an input URL field, HTML fetching and parsing, SEO tag extraction, and visual feedback previews with a total score out of 100. Your success metrics section defines how you'll measure whether the tool actually helps people improve their website performance. Each section serves a specific purpose in guiding AI decisions. The project overview gives context about why this matters. The target audience section helps the AI understand who will use this and what their constraints are. The core features section focuses on what the application must do, not how it should do it. The success metrics section keeps the AI focused on outcomes that matter to users. When you feed this structured information to your AI assistant, it can make informed decisions about user interface design, feature prioritization, and technical implementation that align with your actual goals. Here's the counterintuitive truth that changes everything. Spending an hour on a solid PRD saves you dozens of hours in revision cycles. Most people think this is extra work, but it's actually the fastest path to a working application. Without a PRD, you end up in endless revision cycles where you tell the AI to change this, fix that, and add the other thing. Each change creates new problems because the AI doesn't understand the bigger picture. With a PRD, the AI understands your vision from the start, which means fewer revisions and faster progress toward a working application. The difference in AI output when working with versus without a PRD is dramatic. The structured approach produces cleaner code, better user experience, and fewer bugs. Here's what happens without a PRD. You ask for an SEO tool, the AI builds something generic with basic functionality. You realize it's missing important features, so you ask for changes. The AI adds features that don't integrate well with the existing code. You end up with a messy application that sort of works, but isn't what you wanted. Here's what happens with a PRD. The AI understands your vision, builds integrated features that work together, and creates an application that actually solves the problem you described. Even simple projects benefit from this clarity. Simple projects have a way of becoming complex without clear boundaries. You start building a basic calculator and end up trying to create a full accounting system. The PRD prevents scope creep that kills motivation by defining exactly what you're building and why. When you feel tempted to add just one more feature, you can check your PRD and ask whether that feature supports your original goals. Most of the time, it doesn't, and you can stay focused on what actually matters. Start with these 4 essential sections. Project overview explains what you're building and why it matters. Target audience describes who will use this and what problems they face. Core features lists the minimum functionality needed for the application to be useful. Success metrics defines how you'll know whether the application actually helps people. For each section, ask yourself specific questions. What problem does this solve? Who has this problem? What's the simplest way to solve it? How will you know if it's working? The answers become your PRD content. You can create the PRD with help from AI. You don't need to be an expert in product management or technical writing. Ask your AI assistant to guide you through creating a PRD for your specific project. It will ask the right questions to help you think through user needs, core features, and success criteria. This makes the process accessible even if you've never created software documentation before. The PRD becomes a living document that evolves with your project, guiding not just initial development, but ongoing improvements. As you build and test your application, you'll learn new things about your users and their needs. Update your PRD to reflect these insights. When you want to add new features, check whether they align with your target audience and success metrics. But having a solid PRD is only half the battle. The tools and frameworks you choose to implement your vision can make or break your entire project, especially when working with AI assistants. Framework selection that actually matters. Here's something that will save you weeks of frustration. The framework you choose matters more in vibe coding than traditional development. But not for the reasons you think. It's not about performance or scalability. It's about how well AI assistants understand and work with different tools. Most developers choose frameworks based on what they know or what's trending in the community. In vibe coding, that approach will sabotage your success before you write a single prompt. The AI doesn't care about your personal preferences or the latest JavaScript framework that everyone's talking about. It cares about what it was trained on, and that changes everything about how you should make these decisions. Framework selection is crucial for vibe coding success because AI models are trained on existing code. Popular frameworks with extensive documentation produce better results than obscure alternatives. Think about it this way. If an AI assistant has seen thousands of React projects, but only a handful of some new experimental framework, which one do you think it'll handle better? The AI draws from patterns it learned during training. When you choose frameworks with massive community adoption and comprehensive documentation, you're giving the AI a rich foundation to work from. When you choose something obscure or cutting edge, you're forcing the AI to guess how things should work. For web development, the most AI-friendly combinations center around established tools that have been widely adopted for years. React stands out as the clear winner for front development because AI assistants have extensive training data on React patterns, component structures, and common use cases. Pair React with standard CSS and HTML, and you'll get consistently good results. For styling, Tailwind CSS works exceptionally well with AI assistants because its utility-first approach creates predictable patterns that AI can easily understand and replicate. When you need animations or 3D graphics, Three.js provides the kind of well-documented API that AI assistants excel at implementing. Mobile app development presents different considerations, but the same principles apply. React Native offers the best AI compatibility for cross-platform development because it leverages React patterns that AI assistants already understand well. For native iOS development, Swift with UIKit produces better AI results than SwiftUI, simply because there's more training data available. Android development works best with Java or Kotlin, using traditional Android SDK patterns rather than newer architectural approaches that haven't been widely adopted yet. Here's the insider knowledge that changes how you think about framework combinations. Certain combinations work synergistically with AI assistants in ways that aren't obvious from traditional development perspectives. For example, combining React with Firebase for back-end services creates a sweet spot where AI assistants excel at both front-end component creation and back-end integration. The predictable patterns in Firebase's API design align perfectly with how AI assistants understand data flow and state management. Another powerful combination is Python with Flask for web APIs paired with vanilla JavaScript for front-end interactivity. This might seem old-fashioned compared to modern full-stack frameworks, but AI assistants handle these technologies exceptionally. The simplicity actually becomes an advantage Because there are fewer edge cases and architectural decisions for the AI to navigate. When you're unsure about framework selection, your AI assistant becomes a valuable research tool. Ask it directly. What's the best framework for building a drag-and-drop interface in React? Or which Python web framework would work best for a real-time chat application? The AI will recommend frameworks based on your specific requirements and its understanding of what works well for different use cases. This approach helps you learn about different frameworks while getting practical recommendations for your current project. The biggest mistake I see vibe coders make is choosing frameworks based on personal preference rather than AI compatibility. Your favorite framework might be your worst choice for vibe coding. Maybe you love Angular because you understand its dependency injection system, but if the AI assistant struggles with Angular's complexity, your development process becomes frustrating and slow. Maybe you want to try the latest meta framework that everyone's discussing, but if there's limited training data available, you'll spend more time debugging AI-generated code than building features. Let me show you how the same project requirements produce vastly different results with different framework choices. Imagine building an SEO analysis tool that examines web page tags and provides visual feedback. Using React with standard web APIs, the AI assistant quickly generates clean component structures, proper state management, and effective data parsing logic. The same project, built with a newer, less common framework, requires constant correction and produces inconsistent code quality. The difference isn't subtle. It's the difference between a working application and a collection of broken components. Here's a practical decision matrix for choosing frameworks based on your project type. For beginners building web applications, React plus CSS plus vanilla JavaScript provides the smoothest AI collaboration experience. For intermediate developers who need mobile apps, React Native offers the best balance of AI support and cross-platform capability. For advanced users building complex systems, established enterprise frameworks like Spring Boot for Java or Django for Python provide robust AI compatibility with sophisticated features. You can now make informed framework decisions that accelerate your development process rather than creating unnecessary obstacles. Choose frameworks based on AI compatibility, not personal preference or industry trends. But even with the perfect framework choice, there's one critical practice that separates successful vibe coders from those who lose weeks of work in a single mistake: the art of AI debugging. The skill that separates successful vibe coders from those who give up in frustration is debugging AI-generated code. This isn't like traditional debugging. The patterns are different, the solutions are different, and the mindset needs to be completely different. Most people think that because AI writes the code, it should work perfectly from the start. That's like expecting a first draft of a novel to be ready for publication. AI assistants are incredibly powerful, but they're not perfect. They make mistakes, introduce bugs, and sometimes create code that looks right but doesn't function correctly. Your ability to identify and fix these issues determines whether you build working applications or expensive paperweights that impress nobody and solve no problems. Debugging is the make or break skill for vibe coding, because AI assistants will produce buggy code, and your response to those bugs determines your success. Traditional developers expect bugs and have systematic approaches for finding and fixing them. Many vibe coders, especially those without extensive programming backgrounds, hit their first major bug and assume they're doing something wrong. They abandon their projects or start over from scratch, instead of learning to work through problems systematically. What separates successful vibe coders from those who quit is understanding that debugging is part of the process, not a sign of failure. Every professional application goes through multiple rounds of bug fixing before it's ready for user. The systematic debugging approach for AI-generated code involves understanding common AI mistakes, recognizing patterns and failures, and knowing how to guide AI towards solutions. Traditional debugging focuses on understanding exactly what the code does and why it's not working. AI debugging focuses on describing the problem clearly enough that the AI can fix it. You don't need to understand every line of code to debug effectively. You need to understand what should happen, what's actually happening, and how to communicate that difference to your AI assistant. This shift in approach makes debugging accessible, even if you don't have deep programming knowledge. The most effective debugging workflow follows 4 steps: identify, isolate, communicate, and verify. Identify means recognizing that something isn't working and understanding what the expected behavior should be. Instead of diving into code, you focus on user experience. What should happen when someone clicks this button? What actually happens instead? Isolate means narrowing down where the problem occurs. Which specific feature or interaction is broken? When does the problem happen? Communicate means describing the problem to your AI assistant in a way that leads to effective solutions. Verify means testing the fix to ensure it actually solves the problem without creating new issues. Here's an insider technique that dramatically improves resolution speed. Error message translation. AI assistants respond better to certain types of error descriptions, and knowing how to communicate problems makes the difference between quick fixes and frustrating debugging sessions. Instead of saying it's broken, describe the specific behavior you observe. Instead of copying cryptic error messages without context, explain what you were trying to accomplish when the error occurred. Instead of asking the AI to fix this, provide the error message along with your understanding of what should happen instead. This communication style helps the AI understand not just what's wrong, but what right looks like. Let me walk you through real debugging sessions with common AI-generated bugs. Imagine you're building a task management app, and the delete button isn't working. Traditional debugging would involve examining the JavaScript event handlers and checking the database connections. AI debugging starts with clear problem description. When users click the delete button next to a task, nothing happens. The task should disappear from the list and be removed from the database. You provide this description along with any error messages from the browser console. The AI can then focus on the specific interaction that's failing rather than guessing what might be wrong. Another common scenario involves styling issues where the application works but looks wrong. Maybe your navigation menu overlaps with the main content on mobile devices. Traditional debugging would involve examining CSS rules and media queries. AI debugging focuses on describing the visual problem. The navigation menu covers the main content on screens smaller than 768 pixels wide. The menu should either collapse into a hamburger icon or stack vertically without covering other content. This description gives the AI enough context to suggest appropriate CSS fixes without requiring you to understand responsive design principles. The psychological challenge of debugging AI code when you don't fully understand the underlying implementation can be overwhelming. Many vibe coders feel helpless when faced with bugs because they can't trace through the code logic manually. Here's the mindset shift that builds confidence. You don't need to understand how the code works to debug effectively. You need to understand how the application should behave for users. Focus on the user experience rather than the technical implementation. When something doesn't work as expected, describe the problem from the user's perspective. Collaborative debugging represents a fundamental shift from traditional approaches, where you work with AI assistants to understand and fix problems together. This teamwork approach combines your understanding of what the application should do with the AI's ability to analyze and modify code. You provide context about user needs and expected behavior. The AI provides technical analysis and suggested fixes. Together, you can solve problems that would be difficult for either of you alone. The key insight that transforms your debugging effectiveness is understanding that debugging is a collaborative conversation with your AI assistant rather than a solo technical investigation. You provide human insight about what should happen and why it matters. The AI provides technical analysis and implementation fixes. This partnership approach makes debugging accessible regardless of your programming background, while producing reliable solutions that actually work for users. But there's something even more powerful than effective debugging that can transform the quality of everything your AI assistant creates for you. Advanced techniques and professional workflows. These techniques form the foundation of professional vibe coding workflows that separate serious developers from casual experimenters. Rule-based development transforms how you work with AI assistants by creating systematic guidelines that ensure consistency and quality across larger projects. Think of these rules as instructions you give to a new team member who needs to understand your standards and expectations. You're not just asking the AI to write code, you're teaching it how to write code that fits your project's specific requirements and maintains quality standards throughout development. These rules act as system prompts that guide AI behavior, creating predictable outcomes even as your projects grow more complex. What types of rules make the biggest difference in professional development? Start with coding standards that define how your application should be structured. Specify naming conventions for variables and functions. Define patterns for error handling and user feedback. Establish guidelines for performance optimization and security practices. For example, you might create rules that limit how much code the AI can change in a single response, ensuring that modifications remain manageable and reviewable. You could establish rate-limiting requirements for API endpoints, or mandate that all user registration pages include proper data capture mechanisms. Advanced prompting techniques, including conditional logic, iterative refinement, and multi-step processes, create more sophisticated and reliable results than basic request-response interactions. Conditional logic allows you to guide AI responses based on specific project conditions. Instead of asking for generic solutions, you provide context about current project state and requirements that should influence the AI's decisions. Iterative refinement involves using AI output as input for subsequent prompts, gradually building toward more complex and accurate solutions. Multi-step processes break down complex development tasks into manageable phases that produce better results than attempting everything at once. Here's how these techniques work in practice. Imagine building a complex user authentication system. A basic prompt might ask for login functionality and hope for the best. An advanced approach starts with generating a product requirements document that defines user needs, security requirements, and integration constraints. Then, you use that PRD to guide subsequent prompts for specific implementation details. Each step builds on previous results, creating a systematic development process that produces professional quality outcomes. This methodology ensures that complex features are built thoughtfully rather than hastily. The professional workflow that combines vibe coding with traditional development practices creates a hybrid approach that leverages the best of both worlds. This integration allows developers to use AI for code generation and rapid prototyping, while maintaining control over project architecture and quality assurance. Professional teams don't abandon traditional practices when they adopt AI assistants. They enhance those practices with AI capabilities, creating workflows that are both faster and more reliable than either approach alone. What does this hybrid workflow look like in practice? Begin each project with traditional planning phases that define requirements, architecture, and user experience goals. Use AI assistants to accelerate implementation while maintaining human oversight of design decisions and quality standards. Implement traditional testing and review processes to validate AI-generated code before deployment. This approach combines the speed of AI-assisted development with the reliability of proven development practices, producing applications that meet professional standards without sacrificing development velocity. Implementing proper testing and quality assurance in vibe coding projects requires different approaches than traditional development, but the goals remain the same. AI-generated code still needs validation to ensure it meets requirements and functions correctly. However, the testing focus shifts from verifying your own logic to validating AI-generated solutions against your specifications. This means creating comprehensive test cases that verify not just functionality, but also performance, security, and user experience standards. Version control using Git and GitHub becomes even more critical because you need to track AI-generated changes and maintain the ability to roll back problematic modifications. Scalability considerations become critical as vibe coding projects grow, because early decisions about architecture and tooling have massive downstream impacts. What works for a simple prototype may not support a real application with thousands of users. Professional vibe coders think about scalability from the beginning, choosing frameworks and platforms that can grow with their projects. This often means migrating from beginner-friendly platforms like Replit to more robust development environments like Cursor and Windsurf as projects mature. AI assistant specialization represents an advanced technique where different tools handle different aspects of development based on their strengths and capabilities. Rather than using a single AI assistant for everything, professional teams leverage multiple tools optimized for specific tasks. One tool might excel at generating user interface components, while another handles back-end logic more effectively. This specialization approach allows teams to optimize their workflows by matching tasks to the most capable AI assistants, resulting in higher quality outcomes and faster development cycles. The key insight that separates professional vibe coding from amateur experimentation is understanding that AI assistance enhances rather than replaces professional development practices. The most successful teams combine AI capabilities with proven methodologies, creating workflows that are both innovative and reliable. They understand that the key is to understand the high-level structures and flows to direct the AI effectively. As the AI excels at implementation, you now have the advanced skills and professional workflows needed to build commercial quality applications through vibe coding. These techniques represent more than just improved development methods. They represent a fundamental shift in how software gets built. And those who master these approaches first will shape the applications that define the next decade of technology. Platform wars. Choosing your vibe coding environment. The platform you choose for vibe coding will determine whether you build your first application in days or spend months fighting with setup issues. Most tutorials recommend whatever platform the creator happens to use, which creates a confusing mess of conflicting advice. Some people swear by local development environments with full control over every setting. Others insist that cloud platforms are the only way to go. The truth is more nuanced. Your choice depends on your current skill level, the complexity of what you're building, and your long-term goals. Making the wrong choice early can derail your entire vibe coding journey before you even get started. The major vibe coding platforms fall into two distinct categories: cloud-based solutions like Replit versus local development environments like Windsurf. Each has distinct advantages and trade-offs that affect your development experience in fundamental ways. Cloud platforms handle all the technical setup for you, but limit your control over the environment. Local platforms give you complete control but require more technical knowledge to configure properly. Understanding these differences helps you choose the right tool for your specific situation, rather than randomly picking based on what sounds appealing. Cloud platforms eliminate setup complexity and deployment headaches, allowing you to focus on core vibe coding skills rather than technical configuration. Replit exemplifies this beginner-friendly approach perfectly. You create an account, choose a template, and start coding immediately. No installation process, no environment configuration, no deployment pipeline setup. The platform handles version control automatically, provides built-in collaboration features, and deploys your applications with a single click. This removal of technical barriers lets beginners focus entirely on learning how to work with AI assistants, rather than wrestling with development tools. When you're starting out, this simplicity is invaluable because it eliminates the frustration that makes many people quit before they build anything meaningful. The Powered to You path with local development environments like Windsurf reveals when and why to make this transition and what capabilities you gain from the added complexity. Local environments provide complete control over your development stack, unlimited customization options, and the ability to integrate with any tool or service you choose. Windsurf represents this approach with sophisticated AI integration that works seamlessly with your existing workflow. You can fine-tune every aspect of your development environment, use any framework or library, and optimize performance for your specific needs. However, this power comes with responsibility. You need to understand how to configure development environments, manage dependencies, and handle deployment processes. The learning curve is steeper, but the capabilities are significantly more advanced. Cost considerations that nobody talks about reveal hidden expenses that can surprise unwary developers. Some platforms seem free but become expensive at scale, while others require upfront investment but offer better long-term value. Replit offers generous free tiers that work well for learning and small projects, but serious applications quickly exceed these limits. Storage, compute resources, and bandwidth costs add up faster than most people expect. Local environments like Windsurf require purchasing licenses and potentially more powerful hardware, but these one-time costs often prove more economical for sustained development work. The key is understanding your usage patterns and growth projections rather than just looking at initial pricing. Real development workflows on different platforms using the same project show eye-opening differences in speed, capability, and user experience. Imagine building an SEO meta-tag visual inspector app on both platforms. On Replit, you start with a web template, ask the AI to implement the HTML parsing logic, and deploy immediately to test with real websites. The entire process takes maybe 30 minutes from idea to working application. On Windsurf, you spend more time setting up the project structure and configuring your local environment, but you gain more sophisticated debugging tools, better performance optimization options, and seamless integration with professional development workflows. The Replit version gets you working faster. The Windsurf version gives you more professional capabilities. The hybrid approach combines the best of both worlds, and many successful vibe coders use multiple platforms for different phases of development. This strategy leverages each platform's strengths while minimizing their weaknesses. Start with Replit for rapid prototyping and proof-of-concept development. The quick iteration cycles help you validate ideas and experiment with different approaches without significant time investment. Once you've proven your concept and understand your requirements clearly, migrate to a local environment like Windsurf for production development. This transition gives you the speed of cloud development for exploration combined with the power of local development for implementation. A practical decision framework based on project complexity, technical skill level, and long-term goals helps you choose the right platform systematically. For beginners building simple applications, cloud platforms provide the fastest path to success. For intermediate developers working on complex projects, local environments offer necessary capabilities that cloud platforms cannot match. For experienced developers building commercial applications, local environments provide the control and customization needed for professional deployment. Consider your current technical skills honestly. Evaluate the complexity of what you're planning to build. Think about whether this is a learning project or something you plan to scale into a real product. You can now choose the right platform for your current skill level and project needs, avoiding common pitfalls that derail vibe coding journeys before they gain momentum. But understanding platforms is just the foundation. The real difference between successful vibe coders and those who struggle comes down to mastering techniques that most tutorials never cover. Context engineering for maximum results. That technique is context engineering, and it transforms AI assistants from generic code generators into specialized collaborators who understand your specific project and goals. Most vibe coders treat AI assistants like search engines. They ask a question, get an answer, and move on to the next task. What they don't realize is that AI assistants have memory within each conversation, and you can build up a comprehensive understanding of your project that dramatically improves every subsequent interaction. This isn't just about providing more information. It's about providing the right information in the right order to create a collaborative relationship where the AI truly understands what you're building and why it matters. Context engineering is the advanced skill that transforms good vibe coders into exceptional ones. This is about providing AI assistance with the right information at the right time. Think of it like briefing a new team member who's joining your project halfway through development. You wouldn't just hand them a single task and expect great results. You'd explain the project goals, the target users, the technical decisions you've made, and the constraints you're working within. Context engineering applies this same principle to AI collaboration. You're creating a shared understanding that makes every interaction more effective and every output more aligned with your vision. The different types of context that matter each serve a specific purpose in guiding AI decisions. Project context defines what you're building and why it exists. This includes your application's purpose, target audience, and the problems you're solving. Without project context, AI assistants make generic decisions that might be technically correct, but miss the mark for your specific use case. Technical context specifies the frameworks, libraries, and architectural decisions you've made. This prevents the AI from suggesting solutions that conflict with your existing codebase or require technologies you're not using. User context focuses on who will actually use your application and what their experience should be like. This guides the AI toward user-friendly solutions rather than technically impressive ones that frustrate real people. Constraint context sets boundaries around what you can and cannot do, including budget limitations, time constraints, and technical restrictions. Building comprehensive context documents that serve as reference materials for AI assistants creates a dramatic difference in output quality. Start with a master context document that includes your project overview, technical stack, user personas, and key constraints. Add specific details about your application's features, data structures, and user workflows. Include examples of good code from your project and explanations of patterns you want to maintain. When you start a new conversation with an AI assistant, share the relevant portions of this context document before asking for help. The difference in response quality is immediately obvious. Instead of generic suggestions, you get tailored solutions that fit perfectly with your existing project. Progressive context building offers a technique where you start with basic information and layer in additional details as the project evolves. Begin each AI conversation by establishing the fundamental context about what you're building and what you need help with. As the conversation progresses, provide additional details about specific requirements, technical constraints, or user needs. This approach helps the AI understand your project gradually, while keeping each interaction focused on the immediate task. You're building a knowledge base within the conversation that makes later requests more effective and accurate. Real examples show the stark difference between minimal and rich context approaches. Imagine asking an AI to help with user authentication. A minimal context request might be, "Help me add login functionality to my app." The AI will provide generic authentication code that might not work with your specific setup. A rich context request includes, "I'm building a task management app for freelance designers using React and Firebase. I need to add Google OAuth login that integrates with my existing user profile system and maintains session state across browser refreshes." The login should redirect to the dashboard after success and handle authentication errors gracefully. The rich context version produces code that actually works with your specific project, instead of requiring extensive modifications. The balance between providing enough context and overwhelming the AI assistant requires finding an optimal information density that maximizes effectiveness. Too little context produces generic, unhelpful responses. Too much context can confuse the AI or cause it to lose focus on the specific task at hand. The sweet spot involves providing comprehensive background information at the start of conversations, then adding specific details as needed for individual requests. Focus on information that directly affects the AI's ability to provide useful solutions. include technical details that impact implementation decisions, user requirements that affect functionality choices, and project constraints that limit possible approaches. Context templates for different types of projects provide ready-to-use frameworks that you can adapt for your specific needs. For web applications, include sections for project purpose, target users, technical stack, key features, design preferences, and deployment requirements. For mobile apps, add device compatibility requirements, performance constraints, and platform-specific considerations. For data analysis projects, include information about data sources, analysis goals, visualization preferences, and output requirements. Maintaining and updating context as projects evolve isn't a one-time setup, but an ongoing practice that improves results over time. As you build your application and learn more about user needs, update your context documents to reflect new insights. When you make technical decisions or encounter limitations, add this information to your context repository. Regular context maintenance ensures that AI assistants always have current, relevant information about your project. What makes context engineering so powerful is that it transforms every aspect of your vibe coding workflow. From initial feature development to debugging and optimization, you now understand how to provide AI assistance with the context needed for professional quality output that aligns with your vision. But even the best context engineering skills won't help if you're working in an environment that fights against your productivity at every step. Version control for vibe coders. That practice is version control. And it's the difference between confident experimentation and catastrophic data loss. Last month, a developer lost 3 weeks of work because he trusted AI assistants without proper backup systems. This isn't rare. It happens every day to vibe coders who think version control is optional. Picture this. You've been working on your dream application for weeks. The AI assistant has been helping you build features, refine the user interface, and optimize performance. Everything is working perfectly. Then you ask the AI to make what seems like a simple change. Instead of improving your code, it completely breaks your application. Worse yet, the changes are so extensive that you can't figure out how to undo them manually. Without version control, you're starting over from scratch. Version control is even more critical in vibe coding than traditional development, because AI assistants can make sweeping changes that break working code, and without proper tracking, recovery is impossible. Traditional developers write code incrementally. They add one function, test it, then move to the next feature. If something breaks, they usually remember what they changed and can fix it quickly. Vibe coding works differently. AI assistants can rewrite entire files, restructure your application architecture, or introduce dependencies that conflict with existing code. These changes happen instantly and affect multiple parts of your application simultaneously. When things go wrong, and they will go wrong, you need a way to travel back in time to when everything was working correctly. The essential version control workflow for vibe coding centers on checkpoint-driven development. This means creating save points before each AI experiment rather than after completing features. Every time you're about to ask your AI assistant to add functionality, fix a bug, or optimize code, you create a checkpoint first. This way, if the AI's suggestion doesn't work or breaks something else, you can instantly return to your previous working state. Think of it as creating a restore point before installing new software on your computer. Here's how checkpoint-driven development works in practice. You finish building a user login system that works perfectly. Before asking the AI to add password reset functionality, you commit your current code with a message like user authentication complete and tested. The AI implements the password reset feature, but it accidentally breaks the login system. Instead of spending hours trying to fix the broken code, you simply roll back to your checkpoint and try a different approach. This cycle of checkpoint, experiment, evaluate, and either keep or roll back becomes your standard workflow. The practical Git commands that vibe coders need cover most real-world scenarios without overwhelming beginners. Start with git init to initialize version control in your project folder. Use git add to track all your files. Then git commit memo your message to save your current state with a description of what's working. For example, user authentication system complete and tested. When you want to see your history of checkpoints, git log shows all your previous commits. If you need to go back to a previous version, git reset, followed by the commit identifier takes you back in time. These 5 commands handle most situations you'll encounter. For cloud backup and collaboration, connect your local repository to GitHub. Create a free GitHub account. Then use git remote add origin followed by your repository URL to link your local code to the cloud. Use git push origin main to upload your code for safekeeping. This ensures your work is protected even if your computer crashes or gets stolen. Branching offers an advanced technique that lets you safely test AI suggestions without risking your main code base. Think of branches as parallel universes for your code. Your main branch contains your stable, working application. When you want to experiment with a or change, create a new branch using git checkout. That's experiment name. Now you can ask your AI assistant to make radical changes without affecting your working code. If the experiment succeeds, you can merge the changes back to your main branch. If it fails, you simply delete the experimental branch and return to your stable code. The common objection that version control is too complex for non-technical users misses the point entirely. Modern tools make version control accessible to everyone. Visual Git clients like GitHub Desktop provide point-and-click interfaces that eliminate command line complexity. Many code editors include built-in Git support that handles the technical details automatically. Even if you never learn the specific Git commands, you can instruct your AI assistant to perform version control actions using natural language. Tell it to commit my current changes with a message about completing the user interface, or create a new branch for testing the payment system integration. Real recovery scenarios demonstrate how proper version control saves projects from disaster. Consider a developer building an e-commerce application who asked an AI assistant to optimize the shopping cart functionality. The AI made changes that seemed to improve performance, but introduced a subtle bug that prevented customers from completing purchases. With proper checkpoints, the developer identified the problem immediately by comparing the working version with the broken version, then rolled back to the checkpoint and tried a different optimization approach. You now have a safety net that allows you to experiment confidently with AI assistants, knowing you can always recover from mistakes. Version control transforms vibe coding from a risky process where one bad AI suggestion can destroy weeks of work into a safe environment where you can try ambitious experiments without fear. This confidence changes how you work with AI assistants, encouraging bolder requests and more creative solutions. But even with perfect version control, you'll still encounter situations where AI-generated code doesn't work as expected, and knowing how to handle those moments determines whether you build working applications or abandon projects in frustration. The transformation is already happening around us, and those who understand these principles are building the applications that matter. Vibe coding represents more than just a new development method. It's your pathway to creating software that actually solves problems. Here's your challenge. Start your vibe coding journey today with a specific project. Pick something simple but meaningful. Build a personal dashboard, create a tool that solves a problem you face daily, or develop an application idea you've been putting off. Apply the 4-level thinking framework, create a basic PRD, and choose an AI-friendly platform. Vibe coding isn't a temporary trend. It's a fundamental shift in how software gets built, and mastering it now provides significant competitive advantage.
Thank you.